Good afternoon, everyone. My name is Steve Slusarenko, and I'll be presenting the case for the development of a system to allow utility owners to share information about the location of their facilities with requesters needing that information. I will spend the first 3 or 4 minutes introducing you to our initiative. Then I will turn the floor over to Bob Basques, who will provide a demonstration of a working prototype that was developed by Gopher State One Call. And when Bob has completed his demo, we'll open the floor to questions from the audience. Now, over the last 30 years or so, the various state and provincial One Call centers have been instrumental in supporting the damage prevention capabilities that we have today. We all benefit from their continued hard work, yet they will be the first to tell you that there is more that can be done. And that need for us to do more is the subject of today's presentation and demonstration. We started our underground utility mapping project as a Canadian initiative in the fall of 2021. While doing research on other like initiatives, we came across 2 teams working on similar subsurface mapping projects in the US. And collectively, we decided to work together to share design ideas and our collective knowledge. They are the Minnesota 811 Underground Utility Mapping Project team and the New York University UNUM team that are working on mapping all of the assets underneath New York City. We are now working alongside these teams and several others working on BIM and data sharing initiatives here in Canada. We have a team of over 80 individuals, including 2 members from Minnesota and several from New York University, that represent over 50 organizations in the damage prevention community in the US and Canada. The Canadian Common Ground Alliance last year, or in 2021, reported that the cost of known underground utility infrastructure damage events in 2020 was about 1 billion Canadian dollars. The Common Ground Alliance in the US, the American counterpart to the CCGA, estimated that in 2020, the cost of damage events in the United States was in the order of $30 billion. So we know there's a lot of cost to damage events. In October of 2021, the Common Ground Alliance listed a GIS-based mapping system as a major opportunity to pursue to improve the damage prevention system and stated that the following would result. Locating efficiency. Locates would be done more quickly and more accurately. Excavator safety. Providing GIS facility maps would improve safety for work crews. Cost savings over time. Reduced over notifications, quicker locates, reduced effort to facilitate engineering and design tickets, and reduced risk and costly repairs. So the need for better maps, ticket requesters want the ability to view all of the varied infrastructure from the various utility owners in a common base map to better understand their placement and relationship to each other in an area of interest. We need to provide a simple yet secure method for underground infrastructure owners to exchange infrastructure location data with authorized requesters for a defined area of interest. And owners will want to ensure that their records match what is found in the field by comparing their existing records to what is found in the field, adding tremendous value to them from pre-construction site investigations and locate work. So with that, we're going to have a look at the system that leverages the One Call process. This is a mapping improvement initiative and a data sharing initiative put together by Gopher State One Call, Minnesota 811. So with that, Bob, you may take it away, sir.
Thanks, Steve, for that introduction. It's Bob Basques here. I work for a nonprofit called SharedGeo. We're partnering up with Gopher State One Call and the Minnesota Geospatial Advisory Council Emergency Preparedness Committee for a project we call Fusion View, or it's also known as the Minnesota Utilities Mapping Project. Fusion View is the product that's going to be generated out of this project as an open source package. My day job is I work for the city of St. Paul, Minnesota, in the capacity of doing digital data management, about 350 spatial layers that I manage, and built-in tools for connecting that data set, those data sets into our engineering applications such as AutoCAD or the Arc product line. So got a background in this kind of digital data pass back and forth, that kind of aspect of data management. So on the SharedGeo side, that's kind of my side gig. I'm the technical director for SharedGeo. I've been in that capacity for about 15 years now. And I'm the project manager on the Minnesota Underground Utilities project. This slide here is kind of a broad overview of how the project application called Fusion View is going to work behind the scenes. We'll get back to this in a few slides down the line there, but just showing you basically how things are going to be put together. The idea behind the Fusion View project is that we are building a system that's going to get down to the feature level of data and managing how that data is moved around and shared between the facility owner and the guys that are actually, or guys and gals, whoever's requesting the information through the ticketing system. So the 811 call will come in. They'll define a boundary, which is the black line that you see on the map on the right. And then the Fusion View system is actually setting a 100-foot buffer around that calling polygon and using that to clip the data back to. So while the data is being stored in the Fusion View system, it's clipped back to that 100-foot buffer, and inside of the Fusion View system, that's only set of data that's kept, and it's tied to each ticket individually as that ticket is active. So the technology exists to be able to do this pretty straightforward to actually, kind of apply the technology aspects to this. The bigger deal is trying to figure out how to get everybody lined up and understanding, making sure that the project is satisfying their needs, as well as allaying their fears of, bad actors being able to manipulate their data, that kind of thing. So, viewing access and, the time that people are able to see this information, all those kinds of things are things that we've had to think about as we've moved forward on the project. Common Ground Alliance, which is a national organization in the U.S., they are interested in our project, and actually under their Next Practices initiative have actually done a case study on our project. They've posted that on their website. CGA, Common Ground Alliance, has a pretty big foothold in the underground management of infrastructure arena. So they're very prevalent in that aspect of our project. And one of their big pieces or project initiatives is kind of pushing out into this GIS side of things and making data available a little bit more readily on the 811 side. When we started this project back in 2020, there weren't very many examples of what we were trying to do available at the time to compare to. There's a couple of them here and there, kind of project-based, but nobody that was really trying to do it at the state level like we're proposing here for the state of Minnesota. So jumping into the actual mechanics of this, what you're looking at here is basically the visualization that the Fusion View engine is able to push out now. So we've reached past, we've already gotten past our initial demo version of things. It was basically a proof of concept. And the screenshots that you're going to see in this presentation are coming off of that live system. So I've already talked about the fact that the black line is the polygon that was pulled in from the 811 system. Just to be clear, we're not trying to replace any existing ticketing system. The intent of the Fusion View system is to augment existing ticketing systems with the idea of introducing this feature level data collection, which is based off of the tickets that are actually requested. So you can see this is that kind of initial play into how that data is assembled by the Fusion View system. This screenshot is showing the administrative interview interface that the Fusion View system is configured with. So think of this as something that only the ticket provider, GSOC, which is Gopher State One Call for Minnesota, would be using to manage the Fusion View system itself. This is not intended as an end user kind of view of things. This is just to make sure that the Fusion View engine is running correctly. We can examine data on a ticket by ticket basis. You see there's 3 or 4 tickets here that are stacked on top of each other in this particular view. And the idea is that you can turn layers on and off with the left-hand menu just to examine what's going on inside of the Fusion View system, what data is being stored. You can see that the data sets are all clipped back to those 100-foot boundaries, et cetera. If I click on the map in the administration view, I can change the options here in the left menu, and it'll show me the different kinds of the different available reports for each one of these requests that have been thrown into the Fusion View system. The information coming into the Fusion View system is coming from an existing ticketing system, which I'll get into here in a sec. And then once it's compiled all of its information, it throws that back out as a report that is tied to each ticket. And that information is actually sent back to the end user. Before I get into that side of things, I wanted to kind of review an existing ticket. This is coming out of the Gopher State One Call system. And one of our partners, OCC, is the company that's partnering with us on, they've managed the ticketing system for Gopher State One Call. So this is an example of one of their tickets. And this top part of the ticket is where all the metadata comes from about who requested the ticket, the begin date, end date. All of this information can be passed over into the Fusion View system, and the Fusion View system can handle assigning the information to a particular ticket inside of the Gopher State One Call system. This middle section of their ticket is listing out on the bottom half here the potential facility owners that may have information that overlap the ticket request boundary that the ticket is related to. So if this particular, if any of these facility owners are actually participating in the Fusion View system build out, we'll already have set up a connection with their server, and the Fusion View system will go out to their server and grab any information that is related to this ticket, apply that 100-foot buffer to the boundary, and then clip the data back and store it inside the Fusion View system. This is the bottom third of their ticket, and you can see that they're concentrating on mapping the boundary that was used to actually submit the ticket initially. They're not really working on trying to distribute any of the feature-based information. That's where the Fusion View system is coming in. So we get back into the side of the Fusion View side of things, and again, we're back at that administrative interface there on the right. And then on the left, this is what end user product is currently available from the Fusion View system. All of the information that goes back and forth in between the Fusion View system and the outside, including how these reports are generated, are all of the services of Fusion View are API based. So this particular product that you see here on the left, and here's a detailed view, is actually output based off of an API service on the Fusion View side. So this is a simple HTML page. It's actually a set of different maps that are all individually zoomable. This top map in this particular page is a compilation of all the data that's available that is clipped back to that 100-foot buffer of the main polygon for the request. The information that's available in here is actually only available in the Fusion system between the begin date and the end date that we talked about on the ticket in that metadata section of the ticket. So a begin date and an end date are sent into the Fusion View system to tell the Fusion View system when to purge the feature data from the system itself. At the end of the ticket life, all of the data that's related to the features inside the Fusion View system is automatically purged. So if you take a little bit more detailed view of what we're looking at here, you can see all of these different maps are segregated by, we're using APWA classification of data. The Fusion View system is not intended to describe who owns what, but rather what is where. We really want to know what kind of thing is out in the field and where it's at. The idea is just to augment the tickets again, so that the ticket side of the equation from the GSOC system, we're going to add this on as an extra information that will be accessible through an authenticated and registration system that will be tied into how the facility owners are brought into the system, as well as the types of requests that they want to be solved or handled by this particular service. You can see that the information here is all segmented up into different classifications. The idea behind this output here was generally to, this was a proof of concept to make sure that we could collect the data, segregate it into different classifications. The Fusion View system is going to use that APWA classification as a way of layering the data for presentation to the end user. Okay, we got back to our more complicated slide here. Think of this as a high-level overview of how the Fusion View system works. So initially, the data comes into the Gopher State One Call ticketing center, and they get their request. That information is then sent over into the Fusion View processor, and it records the bounding box and grabs all the metadata information related to that and assigns the ticket number as the ID for all the other subsequent information that's going to be bound to it. That is, Fusion View creates a record at that point inside of the database, and then goes out and grabs potential information from each one of the data providers that has been already onboarded and hooked into the Fusion View system behind the scenes. The Fusion View engine will actually periodically go out and check the services as well when it goes out to the facility owners' data sets, and actually keeps the data up to date during the life of the ticket. Once that information is pulled together from the facility owners' services, Fusion View will take that information, merge it into those APWA layer classifications, and also convert the coordinate system from the source data server into the unified coordinate system that the Fusion View engine will use for publishing. Once that is all done and it's done on the fly, that information then can be sent back to all the different data requests and the GSOC system itself. So obviously the data that we collect on the Fusion View system is going to be bound to the original ticket, and then based on what type of request it is it an engineering request, a locate request, or an excavation request, different types of information may or may not be hidden by default or enabled. But we're going to, in the near term, we've already gotten through this demo phase. We're going to, our next phase of work on building out the project is going to center on the engineering side. Right now, we understand that the engineering aspects of it, the people that are going to be using, or in the organizations that will be connecting up for engineering requests, are going to have a little bit better knowledge of GIS data and how we can handle this feature level digital management aspects. So we're going to work on this, focusing on this engineering aspect as a way of stabilizing the software, then move over into the locate and pushing the data out into the field, as well as enabling the same kinds of activity with excavation, and then way down the line, potentially using a lot of this digital data in an AR form for excavation teams down the line. You'll notice that a lot of this connection arrows here are solid. That's for most of the data that's going out, but there's a couple of arrows there that are dashed, and what those indicate is the fact that the Fusion View system can also collect data from the field. The idea being that if you find an error or something while you're locating, or you need to take a photo and basically announce that there's a problem while you were locating, you can send that information back up into the Fusion View system, and it'll tag it and tie it to the particular ticket as another source of information. Same thing on the excavation side. So the idea there is that we can link into that. The people that are using the ticket out in the field in this digital form can also use the same mechanisms to push data back into the Fusion View system and bind it to the ticket for distribution back to the GSOC ticketing side, as well as any of the facility owners that are enabling the connections. In case somebody was interested in how we're kind of putting the things together behind the scenes, this is a simple schema that we're using for mapping facility owners' data into the FusionView system. The left side is all of the white columns are basic for indexing. On the right side with the columns that are colored are pretty much all of the columns that are required. Actually, they're not even required. There's 2 of them here that are optional. So there's only 5 columns in there that are required to be able to map a data set from a facility owner into the FusionView system. Again, we're not worried about what's there. We just want to be able to replicate in a visualization, what's there and not necessarily who owns it. We've got some collaborations with a few different other folks here, different groups that are doing the same kinds of things. Canadian Underground Infrastructure Register, the CUIR, as Steve mentioned, and a couple of other organizations that we've talked to as we've been moving through on the project. Some of the next steps that we're working on are, developing this piloted version of things that's going to be kind of working around that engineering aspect and solidifying things. We also are going to be improving the map visualizations. When you zoomed in quite a ways, you'll notice that the samples I've already shown you were zoomed out at a few 100-foot level. When you're down at an intersection, there's going to be much more detail on the features as they're displayed, showing dimensioning, how big a pipe is, accuracy, those kinds of things. You'll see in the next version of the output. And then we're going to put some enhancements in place for capturing information from the field, GPS data for locators that are using digital devices to collect data out in the field or actually do their locating and collecting at the same time. Long range plan, the FusionView engine is planned as an open source software package. This has already been agreed to by all associated parties. So the FusionView engine itself is going to be something that will be able to be downloaded and used independently. And again, it's going to be API driven so that it can be integrated into any existing system, commercial and or other open source mechanisms. Then there'll be continuous enhancements added to this particular system as it ages. Just need to know from whoever wants to fund those kinds of enhancements and the kinds of things that they're going to need. But the plan is that there's going to be many more potential enhancements that could be applied to the end product. On the security and regulatory side, there's no laws preventing data sharing. It's a chance to establish standards. We've already got a few potential standards that are going to come out of our development efforts here that I think are going to apply to how digital data might be moved back and forth. We're generally following ASCE standards for exchanging utility infrastructure data. We're focusing on the underground aspects. And then the Federal Geographic Data Committee guidelines from 2005, while they're rather old, are still pertinent to the issues that we're facing here and what we're putting together. So if you get a chance, I would go out and recommend taking a look at that. Some of our kind of next steps is we're currently in the process of establishing an advisory committee from the facility owner side of things. And then we're going to start with the design tickets, like I was talking about, that engineering aspect. And then probably going in with the state, counties, and cities for engineering projects as well. So the commercial side of engineering as well as municipal. Those are kind of what we're going to focus on initially to get the system into a stable form. That's where we're at. Barbara Cederberg is the COO of GSOC, so the Gopher State One Call. She's the chair of the organization. And then Bob Basques, that's myself. I am the project manager for the FusionView system. Thank you.
How do you get involved with the current mapping efforts?
You want to go first, Steve?
Who that's for, yeah.
Well, yeah, I'll answer first, and Bob, you can tell us how you got involved as well. So for me, it was just a conversation with JD Maniscalco from Colorado One Call about 5 years ago about a report that Jim Onspach had put together for the Federal Highways Administration about having the DOTs become the central repository of utility infrastructure in their rights of way. And that's what got me involved with this initially. So, Bob, how about yourself?
I actually go way back on this. I wanted to do something very similar to this. Is kind of like a wish list project for me. I wanted to do something like this 10 or 12 years ago because I didn't think that the technology was lacking to be able to do it. Subsequently found out that it's all kind of policy based is the bigger hurdles to get over. But in this current effort, I just started listening in on some of the meetings that they started having about 3 years ago, actually, is when we started. And one thing led to another, and all of a sudden I'm running the project. So that's how I got involved.
And it's funny, I was doing research to see who else was out there, and I came across one of your recorded meetings from GSOC. So that's how I came across you guys. And of course, Jeff Zeiss was instrumental on both teams here. So Jeff worked with GSOC as well, helping put that solution together.
Yeah, he's always been kind of pushing the whole effort, actually, in general. He bounced in and out of a few of our meetings here and there. So
great. So we're talking about the Gopher State, the Fusionware in the context of the CUIR initiative. Steve, you've put this forward as, I'm thinking, as an example of, look, this is actually being done over here. Is this something we might want to be doing as well? Is that kind of the spirit of it?
Yeah, absolutely. Well, in fact, the first group I came across doing something similar to this was CUIR in the UK, but they're developing a central database, which may or may not be acceptable in the North American context. But in Belgium, the CLIP system in Belgium does, and CUIR, by the way, doesn't involve one call at all. The CLIP system, however, in Belgium, in Flanders, leverages the one call ticket, just like Bob's solution here, and they've been doing it for a number of years now. So it is being done elsewhere in the world and fairly successfully. So, and we know that based on experience that Colorado DOT had on one of their projects using a very similar process, where they gathered all the centerline information from the utilities that had assets in the right of way, and they conflated it and made it available as a map to the bidders, their contractors on their projects. Their line strikes went way down because they just had all this rich information that was readily available and highly accurate. Because what they did was they gathered that information initially, then they went out and did their subsurface utility engineering work and their subsurface utility mapping work, potholed the heck out of the project, and they understood where everything was. And then as stuff went in the ground, they registered right away. They as-built it virtually as it was going in the ground. So another crew a week later didn't come along and dig up something because they didn't know it was just installed the week before. So it was very, very effective and efficient.
Yeah, we heard from the LiDARist in Hong Kong about the fact that the regulatory framework there changed basically when they said you've got to know where everything is once you put it in. I think that's similar to other jurisdictions. It's like, this is something that's going to continue, isn't it? This trend, like these solutions, like we just have to get these systems in place, don't we?
Well, absolutely. And there has to be, some policies in place too. So an example, when I was a project manager on pipeline projects, it was always difficult to get the as-built drawings out of the contractor. Sometimes it'd be 6 or 8 months after the project ended before you got the as-builts. So we'd always hold back a bunch of money to make sure that we could either pay for that as-built ourselves or at least get it delivered to us. And that was always an issue. Now with the technology, you can as-built on the fly. Literally, you can gather that data every time you take a shot. You can put it up into the cloud, send it off to the owner.
Absolutely.
Yeah, there's all kinds of potential going down the line here as we move forward on this to integrate new technologies and collection methods. So I think we're just kind of right in the sweet spot of starting to put this together. And between myself and Steve's conversations, I don't think we're doing anything that conflicts with your approach or what you want to do on the Canadian side either, is it?
No, I think we're perfectly aligned. So, so there are, we have this working group, so with Bob and his team, and also the folks at New York University, and we're all working together to this common solution. And we want to make sure it's homogeneous and covers, it's kind of a North American solution. You could take it internationally if you wanted to. You could work in Australia or Hong Kong or Thailand or wherever. It really shouldn't matter. It's the same, should be the same process.
And so for the people that might not be familiar with CUIR, Steve, we're still looking for engagement. Like if people come forward and say, oh, that's an interesting, I think I have something I can add to that or help. All of the groups are very welcoming to that, aren't they?
Absolutely. We're always looking for people to get involved with us and let us know that they're out there and to contribute what they can in terms of either experiences that they've had in the past or visions going forward to say, hey, we'd love to be able to do this. It would really help us out, especially if you're, in the damage prevention industry itself and you're having issues with maybe in your region with contractors not paying attention or whatever it is, not putting in one calls. There's all kinds of reasons to get involved and help us all out.
Great. And kind of keeping along with our theme of touching base with people that knew Jeff and worked with Jeff, would each of you care to share an anecdote of working with Jeff, maybe something that you learned from Jeff or a way that he inspired you?
Well, I had him actually write up a blog about me 4 or 5 years ago on I've got a long-lived project at the city of St. Paul. That's my day job. And he wrote up a blog about me, and it was out of the blue, literally. He sent me an email and said, hey, I'm writing this up. And, he saw one of my presentations at a conference or something, and then followed up with me on writing the blog. But that kind of got me going and actually made me be a little bit more honest about what I was doing and how I was describing it too. So that would be my probably first major interaction with them.
That's great.
Yeah, no, it's Jeff was just an incredible individual and a wealth of knowledge, quite a statesman as well, a very, very diplomatic person, and but he could kind of wry too. He had a sharp sense of humor too. But I'd known Jeff for about 5 years. I guess I'd hooked up on LinkedIn with him, and then when I started thinking about putting this together, he was the first person that I reached out to join the CUIR team. And he was the first person that did it. So he was the first phone call I made and the first person to join us. And he said, this is perfect. This is quite aligned with what I've been trying to do for years as well.
Yeah, he was also a founding member of our project. So when we started up, he was right there.
Yeah, that's just the kind of guy he was. And, he passed away September 14th. I think probably last meeting we had in August, he was there. And I'm sure he was at his hospital bed. Just the kind of guy he wasn't sort of interested that he had and kind of the passion he had for what we're trying to do.